We're ready now to take our leap from the Bohr model, which had lots of good points. Remember, the Bohr model was mathematically and experimentally with our emission line spectra supported and explained the spectral lines. Remember those little lines that we see through our spectroscopes for hydrogen? And for a while, scientists were like, okay, you know what, this is good. Then we can use this mathematical model that Bohr's come up with and apply it to atoms of all the elements. But it turns out, nope, that didn't actually work. All this beautiful system that worked perfectly for hydrogen with its one electron kind of falls apart everywhere beyond that. Okay, so however, Bohr's model did not apply to the spectra of elements with more than one electron. So now we're ready to shift then from the Bohr model, since we're seeing, hey, this only works for atoms with one electron, to something that can better describe the energies of electrons for all atoms. And that's how we introduce ourselves to our current understanding of the atom, which we call the quantum model. Now it probably makes a little more sense to you. It's going to have to deal with quanta. Now, something to note, this is our current model. Now, it's stood since the early 1900s, 1930s era, but there's always the possibility that it's going to be refined and changed. This may not be the final story. Okay, so looking at this, there's a guy named deBroglie. Before we talk about deBroglie, let's just review real quick. We talked about Einstein, and Einstein talked about wave-particle duality for light or electromagnetic radiation, how light could act like a wave, or it also could act like a particle. We'd call that particle a photon. Well, in 1924, this is when this guy named deBroglie said that, hey, maybe that could be true for electrons too. He said that electrons could have wave-like properties. And so he said, like, hey, you know what? Maybe we should think about electrons as waves, but they're confined or they're stuck. Okay, the word confined just means like put in a certain way or put in a certain area, in this case, to a certain area around the nucleus. So electrons could be considered as waves in a certain space around the nucleus. And so if we were to look at a drawing, it says draw an example of a proposed atom. I'm just going to show you a couple here. So this could be one example of deBroglie. Imagine this is the electron and it's going to kind of follow this wave-like pattern around. Here we could have 3 different wave nodes, we'd call them, or 4 or 5. And so what we're shifting from is Bohr saying, hey, they go in these perfect little rings, to deBroglie saying, hey, they're electrons that have waves. Notice that the wave pattern has to fit, right? It always closes the circle. We're not going to get a ton into deBroglie. I just want you to be aware he's the first one to be like, hey, you know what? Electrons can act like waves and particles too. They can have wave-particle duality as well. And then while we're on the track of talking about the electron as a wave, let's fill in our box here about Schrodinger. Now, Schrodinger, that name may ring a bell to you. Sometimes the quantum model is called Schrodinger's model. Schrodinger used that idea from deBroglie of an electron acting like a wave, and he developed a very kind of intense equation, we'll call it Schrodinger's equation, to help describe where the electrons might be. So remember, Bohr had a similar thing. His was a little more simple, and it worked really well for one electron. The Schrodinger equation is going to treat electrons as waves. And when it does that, it was actually able to provide specific frequencies and specific energies of all the different electrons for all the different elements. So Schrodinger's is kind of like Bohr's model, but amped up a bit, and now it can cover all of the different elements. And the linchpin, the thing that made that work, was the fact that we needed to treat electrons as waves, and then could use a whole different set of equations to describe their energies, frequencies, all that good stuff.